So, we have finished standard penetration test, plate load test, DCPT. Now, cone penetration test. Cone penetration test to measure tip resistance as well as frictional resistance. Generally, it has been used for design of your pile foundations. Now, for cone penetration resistance test or cone penetration test CPT, it is called CPT. A cone having 10 centimeter square cross sections, and this cross section is your 10 centimeter squares, and there is a cone at the bottom. So, this has been arranged in such a way that you can measure. If I go for a cone resistance measurement, cone resistance versus your depth, if I say resistance versus your depth, I can get cone resistance, I can get total resistance. So, total resistance minus cone resistance, I can get frictional resistance. What will happen? Once you insert it, there is a lock system here. If you lock it, then what will happen? This part will be locked, this part will be locked, only cone will be go inside. Once cone will be go inside at regular depth, every 1.5 meter or 1 meter or 2 meter interval depth wise, you are going to measure tip resistance. Then what happen? Then you bring it back, then you unlock, then lock total your enter cone pipe, enter cone as well as side pipe. So, it will move all together. Once it will move all together, what you are supposed to get it? You will get both cone resistance as well as side resistance. That means, it will give you total resistance. If it moves all together, it will give you total resistance. So, depth wise you can measure cone resistance as well as total resistance. Once you get total resistance, so from total resistance you deduct your cone resistance, you will get side resistance. That means slip friction or frictional resistance. That means, if it is a frictional pile design, what is your frictional resistance, particularly that side you can get it, and here you can get it a end bearing resistance, or it is a called tip resistance. Now, you see another part I forget, friction ratio Fr is equal to Fs by Qc. Fs by Qc, Fs is your slip friction or frictional resistance, and Qc is your cone resistance into 100%. So, typically it is 0 for granular soil, it varying from 0 to somewhere else here, and 10% is your cohesive soils. So, how you are going to get it? If you look at here, I can get a tip resistance as well as frictional ratio or frictional resistance from cone penetration test. It is a continuous test, sounding test. You will get variation of your tip resistance as well as cone resistance over a depth. Whatever the required depth, you are going to find it out, you will get it. These are the different cases, case stories, different cases. You see there are different types of soils, SM, clay silt, dense sand, stiff clay, you can get it. What is your tip resistance, frictional resistance? Also it has been modified, cone resistance. Now you can get it pore water pressure also, you can get it pore water pressure. This instrument has been modified so that directly you can get liquefaction resistance, or you can measure also pore water pressure. So, this case the cone penetration test has been changed. It has been now, it has been said electric piezo cone. Electric piezo cone particularly in electric piezo cone what you are supposed to get it. Earlier in cone resistance you are supposed to get tip resistance as well as side resistance. In electric piezo cone what you are going to get it, tip resistance, side resistance, then your pore water pressure or pore pressure. Once you are getting your pore water pressure, then once your excess pore water pressure is equal to your effective stress, that means excess pore water pressure ratio if it reaches to 1, that means at that state we say that soil may lose its strength. So, you can get it liquefaction potential or liquefaction resistance of a soil. If you look at, this is a simple soil profile up to a depth of 25 meter of silt, clay silt, dense sand, steep clay. If you look at here pore water pressure, here there is no change in pore water pressure, all of a sudden between dense sand to up to steep clay there is a change in pore water pressure. So, this is a continuous process. This is a continuous process, you can get it. Now, it has been changed cone penetration test to electric piezo cone. In electric piezo cone, and there is a pore water pressure transducer, they put it here, so that you can get it what is the change in pore water pressure in your soil. There is a pore water pressure transducers. So, this is what you are supposed to get it. Then cone penetration test, SCPT correlations. If you have a SCPT in clay, how you are going to get it? In sand, in clay, what is the value of your on drain shear strength? You can get it directly from your cone penetration test, and in sand you can get it E, modulus of elasticity. So, Cu on drain shear strength is Qc minus sigma V, Qc cone resistance, sigma V overburden pressure, and Nk is your cone factor, it varies between 15 to 20, and from there directly you are getting a strength. On drain cohesions value of in clay, every layer wise you can get it. Similarly, in sand you can also get E, modulus of elasticity. For normally consolidated sand, it is varying between 2.5 to 3.5 Qc. Qc is your cone resistance. Qc is your cone resistance. If you look at here, Qc is your cone resistance, that means this resistance is your cone resistance, Qc total, Qc cone resistance, and sorry I say wrong, this is your tip resistance, this is your Qt, and Qc is your cone resistance. From cone resistance you can get it Cu as well as modulus of elasticity. Also from cone penetration test you can find it out phi, angle of friction, or phi prime. If you look at here, I put it, these are the two correlations has been given. One is your Peck et al. 1974, another one Mayer of 1976. If you look at here, first one is your standard penetration resistance, I have covered N, blows per 30 centimeter or 300 mm, and this is your angle of shearing resistance. This is a curve, there is a curve. So, from here whatever in the field you are getting SPT value N, you take it and put it here, and where it cross you can get direct value of your phi, angle of internal friction, once you know the SPTN value. Similarly, static cone resistance, if you know the cone resistance value, here I put it very loose, medium dense, dense and very dense. Once you get your static cone resistance value, you can extrapolate and you can get value of angle of internal friction phi. That means I am getting many parameters from here. from SPTN as well as cone resistance QU or QC, I can get phi, I can get E, I can also get Cu value. Then next test is your dilatometer or pressure meter test. So, I will have to go now onwards slightly fast because there are a lot of course content and syllabus. Main focus is your foundation design. So, these are all basic site investigations. So, it has been developed by Marchetti. It is in situ penetration plus expansion test, simple, easy to operate, best suited for, look at here, best suited for sand, silt, clay and organic soils, not used in hard rock. So, from this dilatometer test what you are supposed to get? Coefficient of lateral earth pressure K0, this is particularly retaining wall structures where you have to find it out K, Kp, you need to have your K0, over consolidation ratio, coefficient of consolidation Ch, on drain shear strength Cu, coefficient of permeability Kh, unit weight of soil also you can get it, equilibrium pore pressure or U0 you can get it. So, the dilatometer right now it has been modified to be seismic dilatometer, where you can get it pore water pressure, change in pore water pressure, from there you can find it out also, from you can get also shear velocity also you can measure also, there are arrangements. So, it consists of blade with membrane. So, control unit, pneumatic electric cable, pressure source, electric ground cable. What are the working principles? It is a stainless steel membrane, look at here, stainless steel membrane and sensing disc, it is a sensor, and there is a plexiglass cylinder, this is a plexiglass cylinder, plastic insulating sheets, and there is a stainless steel cylinder, electric wire and it compacted here. Basically what will happen once you push it inside, it will not expand vertically, rather it will expand laterally. That means if I want to get it earth pressure at rest sigma 3 by sigma 1, so sigma V is your overburden pressure, sigma 3 is your lateral. So, once it expand, at the same time it try to push the soils. So, laterally the soil fell or maybe tends to fail, you will get sigma 3 value, and up to what depth? This is the depth, suppose say 2 meter. If you know the gamma into h, you can find it out sigma V0. So, sigma 3 by sigma B or sigma 1 you can get K0. This is the basic principle. So, these are all procedures, you pushed inside vertically down to the test depth, then the one vent valve will be closed, slowly laterally it will expand and it will give a signal. There are signals outside, you can very easily note it. Also there are outside also how much pressure it expand, you can measure also outside. So, there are different DMT reduction formulas, corrected first reading P0, corrected second reading, material index, horizontal stress index, dilatometer modulus ED from P1 and P0, K0 coefficient of earth pressure you can find it out, over consolidated ratio and Cu. You see what are the parameter you are supposed to get it, K0 over consolidated ratio, Cu on drain cohesion, phi friction angle, Ch coefficient of consolidation, Kh coefficient of permeability, gamma is equal to unit weight, U0 pore water pressure. All parameters you are supposed to get it. So, there are different charts available, slightly it will be higher side. So, this is all about your flat dilatometer. It is inexpensive, no need to go for borehole, quick estimates of a number of parameters, you can very quickly get number of parameter K0, Cu, phi and your consolidation parameter, permeability parameter, DMT are expressed in terms of 3 index parameter Kd, in situ K0 and Ed. As I said earlier, used in clays, silt, sand, even soft rocks, not used for hard soil through which the blade cannot penetrate. If you look at here, look this figure, there is a blade, this is called flat dilatometer because it is in a flat shape. This blade has to penetrate, push to inside. So, if there is a hard rock, it will be difficult to push. Very easily once you push it outside, you can very easily record it all the parameters, you can very easily find it out, C, phi, coefficient of permeability, K0, E, all the parameter you can very easily got it. Pressure meter test also there, pressure meter test I will slightly discuss latter part. Now come to go to the second half the part I have left previously, disturbed versus undisturbed. How do you know that good quality sample necessary? If your area ratio is less than 10%, that means if this is your sampling tube, outside diameter, this is your outside diameter whole square, outside diameter, then minus inside diameter whole square divided by inside diameter whole square into 100%. Whatever the sampling tube you are using, you should be able to know whether you are getting a good quality of undisturbed soil sample. No soil sample is undisturbed. Once you are collecting the soil sample below the ground surface, it is partially disturbed. So, in engineering, particularly in civil engineering, in geotechnical engineering, if you say area ratio is less than 10%, then we can say that good quality of sample collected, that means your undisturbed sample has been collected. Thicker the wall, greater the disturbance. More thick walls, your sample will be getting disturbed. If you remember well, I say earlier, for SPT test we push split spoon sampler. Split spoon sampler means I can split it longitudinally equal parts. So, whatever samples we are getting from the SPT test, if you look at the area ratio, outside diameter is 51 mm, inside diameter is 35 mm. So, area ratio is 112%. That means you are not getting undisturbed samples. Once you are not getting undisturbed sample, that means it is disturbed. You cannot use this sample for measurement of your engineering property, particularly phi and Cu in your laboratory like triaxial consolidation, no. It will be done only for classifications. Look at here, soil samples collected in split spoon sampler, this is your split spoon samplers, it has been opened, you can connect it. The area ratio is 112% and soil samples collected, so it has been used for your classifications, not for engineering properties. Common sampling methods, these are details, common sampling methods, split barrel, split spoon, what you are supposed to get it, disturbed, thin walled Selby tube. Generally in India, everywhere else you are using thin walled Selby tube on disturbed samples. Appropriate soil types: clay, silt, fine grained soils, clay, sand. It has been mechanically pushed, and split spoon, if you remember, hammered. Once you hammer, you are supposed to get disturbed sample, you are not supposed to get undisturbed sample. Continuous push, partially undisturbed, sand, silt and clay, hydraulic push with plastic ring, piston samplers, undisturbed you are supposed to get it, piston samplers used for silt and clays, and it has been pushed by means of hydraulically or hydraulic pushed. Pitcher undisturbed, steep to hard clay. Why I am saying it? These are different sampler tubes, and it has been particularly classified which sampler tube you are going to use for what kind of soil. If it is a steep to hard clay, you cannot use your thin walled Selby tube. So, in that case, pitcher undisturbed, it has been collected by means of rotation, means by means of rotating you push it inside. Denison, undisturbed sample you are supposed to get it, steep to hard clay, silt, sand and partially weathered rock, and also how you penetrate it, rotation and hydraulic pressure. Modified California sampler tubes, it has been used in United States. So, this is a disturbed, you are supposed to get disturbed samples, sands, silt, clays and gravels. Look at here, method of penetration, you are hammering it, hammer it and driven, hammer and drive it. Continuous auger disturbed, particularly cohesive soils, and drilling by means of hollow stem augers. Bulk disturbed, gravels, sand, silt and clay, hand tools, bucket augering. Block undisturbed, cohesive soils, frozen or resin impregnated granular soils. This table is for a kind of comparative study. Once you go after graduating, once you go in any of your construction company or design where these are all your set of sampler tubes, you will recommend as an geotechnical engineer, if you are going to collect undisturbed sample, go this. If this is your soil type, then this type of sampling tube you have to use to collect your undisturbed soil samples. Rock sampling, in brief, I do not want to go in rock because it is beyond our scope. I have covered this pit sampling, trial pit, just I am showing the figure. Trial pit or pit sampling is possible only in case of clays. You can open a pit and very easily you can push the sampling tubes. Bore holes 75 mm dia and 10 to 30 meter you can push it by means of drilling rig. Boring tools, as I said, auger boring, power drill. Look at here, I have earlier drawn it, but I am showing it manually. Helical auger, post hole auger. What happened? These are for boring, to make manually boring, or power drills. By using power drills also you can bore it. These are manually you can use it. Also wash boring, I have discussed your wash boring. Now boring tool, if you look at here, this is your scraper bucket. By means of rotation it has to be pushed, drill rod, this is a scraper bucket. Now look at your Selby tube, thin walled Selby tube. Once borehole has been made, in the drill rod this thin walled tube has been connected, and it has been, look at here, in the drill rod it has been connected. Either you can use manually or you can use piston also, piston sampler. Here it can be used manually, you can push it inside. So, soil sample will be collected, undisturbed soil sample, or there is a double or single piston. By means of piston action you can push it inside, you can collect undisturbed soil sample. This is what the boring tools, and I will take one more class afterwards how to prepare your bore log data, bore log charts, what information you want to give. This is all about a brief description, not in details, about your soft soil investigations. Once you get your soft soil investigation, you prepare a report. That report has to go for your design sections. Based on that report, they will take a call what kind of foundation they are going to construct. Thank you.